Hi girls, this is the second part of the lesson. Sorry I had to do it in two parts, but I ran out of time in the first part. So we got to the point where we figured out what part A is. So we ended up getting this answer. And that's okay because H is just some value where it's a bit further from X. So as we saw in the example above, we had X and X plus H. So H just represents some value that makes another coordinate H unit apart. Okay, and now let's do B. So if I take the limit as X approaches H of what we had in part A, so this bit is what we got in part A. So I don't have to do this part again because I already know what that is, but I do need to take the limit of it. Okay, so let's just skip a step and just say, okay, well, I already know that that's 4x plus 2h. Okay, and I'll just say from part A. So the marker knows where I got that from. And to find the limit of that, I just say, okay, well, let's sub h equals 0 in. That's usually how I find the limit of something. And so the limit as x approaches 0 is 4x. Now, this we can say is f dash x, because technically this is the gradient function, much like how we saw it above in the first example where I said, okay, well, the gradient function of half x squared was x, and then obviously y dash is that. So that's the equivalent of what's happening. So the gradient function is that, and so I would have to sub in x values to see what the gradient is as a specific point. So let's say I subbed in x equals 1. Okay, the gradient of the tangent at x equals 1 would be, just sub it in, it would be 4. So the gradient at x equals 1 is 4 of this particular graph. Okay, but you would obviously stop here for the final answer. And you wouldn't write f dash x, but I'm just showing you what that would mean. Now, for the resulting answer in part A, that tells you the gradient of the secant or chord for some arbitrary value of h. Okay, and part B gives you the gradient function, okay, which we denote with f dash x or y dash or dy on dx, any of the notation you saw as long as it makes sense. When you substitute a value of x, that will be the gradient of the tangent at that specific point. So this is a little bit of a warm-up of this. So example 3 is the bulk of this lesson. So when we're asked to differentiate something, we're finding the derivative function or the derivative or the gradient function at a and then we'll find the gradient at a specific point. Now, they've told us they want us to find the gradient of this graph at the point of x equals 1. Now, if I were to give you a quick drawing, this graph is a parabola shifted up 3 units. Okay, and they want me to find the gradient at x equals 1. Okay, but I need the gradient function first to do that. So that's where first principles comes in. So we say, okay, well, I know that y equals x squared plus 3. Okay, so you could say y dash equals limit as h approaches 0, because that's the technical definition of it. So you need to use this formula all the time. Okay, so you know that f of x, let's do that again. Let's rewrite it with f of x because it just makes more sense. So f of x equals x squared plus 3. You know that f dash x is the limit as h approaches 0 of f of x plus h minus f of x over h. Okay, and we also need to find f of x plus h, which is just this, but instead of with x, we have x plus h all squared. So replace this with the whole expression, plus 3. Expand it out, so x squared plus 2xh plus h squared plus 3. And then sub both of those values, so sub this into where this is, and sub this for f of x. Okay, so f of f dash x equals the limit as x approaches 0 of x squared plus 2xh plus h squared plus 3 minus x squared plus 3, and I put it in brackets because I'm going to have to expand the minus out, all over h. Okay, and it's really long, but there will be a shorter way to do it. You just need to understand the foundations of it. Okay, and then expand the minus out. Feel free to pause the video if you just need to understand what's going on, but I'm just going to keep going. So x squared minus x squared disappears, plus 3 minus 3 disappears, so I'm really left with 2xh plus h squared on h, and then I want to eliminate the h at the bottom, so factorize it out. Cancel, cancel, so you get ln h approaches 0 equals 2x plus h, and then that just ends up equaling 2x plus 0, which is just 2x. So f dash x, so the derivative function, is 2x. So I found that. Now to find the specific point or the specific gradient at x equals 1, then you say, okay, well, let's sub it in. When x equals 1, the gradient is 2. Okay, have a go at B on your own. Okay, you're just differentiating, you're not finding a specific gradient. So you should just end up with, and I'll give you the answer. Let's see if you can do it, and I'll check next lesson. You should end up with 4x plus 7. Okay, once you've done that, go on to do the worksheet underneath, and feel free to ask me for help if you're still not sure how to do it. Thank you.